Hi there. In this video, we're just going to go through an introduction to an overview of clutches and brakes, and I'm sure many of you would have seen at least some of this stuff before. But anyway, let's get into it. So first up, clutch, device used to connect or disconnect a driven component from the prime mover of the system. So typically our prime mover is a motor, or it could be an engine. And then we've got some kind of an output. So here we've just got a belt drive, and in this case we want to sometimes disconnect and then reconnect the output from the input. So the way we can do that is with the clutch. A brake is, as you're probably all well aware, a device to bring a moving system to rest, to slow its speed or just to control its speed to whatever value we want. So here, same kind of system, just a motor with an output, belt and pulley drive, and then here's some kind of a brake to control the speed. And then we can also have a clutch brake module, which is a combination of a clutch and a brake in just a single system. So when the clutch is activated, the brake will deactivate and vice versa. Okay, so that's that. So firstly, looking at the basic operation of a plate, clutch or a brake. Basically all we've got is one plate that's rotating, and then to get that input rotation to the output, we just bring the two flat plates together. Okay, and the power is transmitted from one plate to the other through friction and the friction torque that's generated. Okay, and just got a little GIF there, just showing the actuation and pushing against these springs, which we'll see in more detail later, that actually opens or disconnects the output from the input. All right, so let's go to, so I've got a little bit of a video here. Hopefully this kind of works. So let me play that.
How does the clutch work in a manual transmission car? Let's see how. Here's the input shaft.
So I've got the input
it's
shaft.
the arm that connects the engine and the gearbox. Here's the clutch system. Let's look inside. This is the flywheel. It's connected to the engine and spins continuously. This is the friction disc. It always holds onto the flywheel and spins with it. Since the disc and input shaft are connected, the input shaft always spins too. This is the clutch cover. It's attached to the flywheel and spins with it as well. Underneath it are the diaphragm spring and pressure plate. Let's temporarily pause the spinning of the cover, spring, and plate to see how the clutch system works. When you press in your clutch pedal, you're pressing in the diaphragm spring. The outer edges of the spring bow outward and pull the pressure plate away from the disc. The disc disconnects from the flywheel and the input shaft stops spinning. When you release the clutch pedal, the opposite happens and the disc reconnects with the flywheel. Now that you know the basics of how a clutch works, in our next video we'll show you the best way to use the clutch to drive stick shift. Subscribe!
Okay, so hopefully that was illuminating. And as you can see, there's many different YouTube videos that you can watch to help understand how a clutch works. So, all right, so here's just a few more pictures to have a look at that in detail. So just a static image of what's happening in the clutch in a typical automotive transmission. So here you've got your foot off the clutch pedal, so it's just sitting there, and while your foot is off the clutch pedal, the clutch is engaged. Okay, so the disc or the pressure plate and the clutch disc are connected, and torque is being transmitted. When you push your foot on the clutch pedal, you disengage the clutch, so these springs deflect and pull the pressure plate away from the clutch plate. Okay, that's basically it. I'm sure there are better explanations than on one of those videos that you just saw after the previous video. But basically you can see the general operation where you have two flat plates forced together in order to transmit the rotation through friction. All right, some more GIFs so you can see that happening as we press this in. These springs, or the diaphragm springs, deflect and pull the plate away from the clutch plate, so we have no transmission of torque from one to the other. And you can see here also again, so moves out, clutch is engaged, things rotate together, press in, deflect the springs, that pulls the plate away, so they're no longer in contact, and so no torque transmitted. So this one's showing I think this one is actually slightly different. I think this one is working the opposite way. So when it's like this, it's disconnected, and then when we pull it, it starts to connect just momentarily, and then the rotation is transmitted. So you can see this will slow down, and this plate here slow down and stops. Then it's engaged again, rotates for a little while, and then because it's disengaged, it eventually slows down. Anyway, you can watch that a bit more at your leisure. Okay, so by convention the term clutch is for the application in which the connection is made to a shaft parallel to the motor shaft. Okay, so something like this. If the connection is in line, then that's often called a clutch coupling. Okay, so here everything is in line. Okay, it's terminology. Also, by convention, a brake is actuated by some overt action, so the application of fluid pressure, or a lever, or you pull a handle, or an electric current if it's an electrically energized brake. If it is an electrically energized brake, what we'll often do is have a fail-safe. So what that means is, if the power is turned off, then the brake is engaged, so nothing can happen. When you turn the power on, it disengages the brake and allows the transmission components to rotate. So what happens there is, if you lose power all of a sudden, it fails in a safe way such that the brake is energized. And I've got some pictures later on showing you how that happens. So usually it's the brake is activated or is engaged by the force of a spring, and then when you turn the power on, you pull against or push against that spring to disengage the brake, and then if power goes off, then the spring will push the brake back on to stop the load from rotating. All right, what else have we got here? Okay, so just some more details and more pictures of the clutch brake module, where you've got the clutch and the brake combined into one unit. Okay. All right, so another type of braking system that you would be familiar with would be the caliper disc brake, where we have a disc or a rotor, and then the braking is achieved by having brake pads that are forced onto the disc to stop it from rotating. Okay, usually or often that will be via hydraulic pressure, or could be just air pressure. I've actually also seen on bicycle disc brakes where like a cam and a lever or cable is used to activate this caliper disc form of braking. Okay, what else have we got? Okay, so here's just a quick video showing you that. So we've got here activated just by levers. So push on the pedal, got a linkage here, pulls on the these links here, and you've got the pads mounted on some levers here, which then, as we pull here, that forces these two pads together and clamps onto the disc to stop it from rotating. Cone clutch, so just in the form of a cone, force the two parts together to enable the transmission to be, or the rotation to be transmitted from one shaft to the next, or to stop a shaft from rotating through friction being generated on those cone or those conical surfaces. Bit of a GIF showing you that happening. It's not all that enlightening, I guess. You can replay this bit of the video if you really want to. Okay, next we have a band brake. Very simple but effective means of braking and stopping rotation. So just have a wheel or a drum that rotates, band wrapped around it. Actuation force on the band tightens against the drum, friction's developed, so we get a tangential force and therefore torque to stop the drum from rotating. And another quick video of that. Pressing down on the lever presses or brings the band in contact with the drum to stop it from rotating. Pretty simple. Block or shoe brakes. So here we've got a rotating drum, block here, lever pivoted over here, actuation force and friction developed between the block or the brake shoe to stop the drum from rotating. So back in Intro to Mechanical Engineering or Applied Mechanics and Design A, or Fundamentals of Mechanical Engineering, I would have got you to do free body diagrams and equilibrium equations and friction equations in order to work out what actuation force is needed in order to stop a drum that has a torque of whatever applied to it. And then we have similar, a long shoe brake. So the long shoe brake, the pad or the shoe is actually covers much more of the circumference of the drum. And here we've just got two together. Actuation force closes these up and the pads act on the drum to stop it from rotating. So hopefully you've all seen this kind of thing before. And here's just a quick video of the block or shoe brake. So here we just push down on that block and that curved surface to stop the wheel or the pulley from rotating. And here we can see the long shoe brake, where these shoes, when we apply the force here to overcome the force of the spring, which is holding the shoes away from this drum, so we apply the force, pushes that out and stops this drum from rotating. So this one's not actually rotating in this video, but you get the idea. Okay, so this is often called a drum brake, typical on the rear brakes of older cars. Still see them on some cars these days. Also trailer brakes, you'll see drum brakes like this. So yeah, push your foot on the pedal. Hydraulic force pushes the two drums apart. When you take your foot off, the spring here brings them back together and draws the shoes away from the drum. Okay, typical automotive braking system. So often you'll have disc brakes at the front, drum brakes at the rear, master cylinder, to distribute the hydraulic pressure throughout the system, and then you have a combination valve which gives you your brake balance front to right. So a certain percentage of the load or the braking force will go to the front and a certain percentage will go to the back, depending on what balance you want. Okay, other types of clutches and brakes, there's a whole list of things here. You can look those up. This one here, if you've got an old laptop computer that's broken, break off the screen and have a look inside, and you'll see that this is the mechanisms that's used for opening your laptop screen and holding it in position. Okay, pretty clever. And here we've got a fluid coupling, also known as a torque converter. Okay, so you see this a lot in automatic transmissions. Okay, and don't need to go into that. We're not going to spend much time or any time on that in this subject. Different ways of activating your brake or clutch. So manual, just with a lever, as we've seen in some of the previous video slides. So here's one for a power takeoff. Now you may not know what a power takeoff is. So a typical example would be on a tractor. So if you want to do some other work that requires rotational input, so instead of carrying around an electric motor, you can just have the engine of the tractor running, and then you've got this output shaft that you can connect to in order to do whatever it is that you need to do. You might want to run a pump, a water pump, for example. So yeah, so that's a power takeoff. Spring applied. All right, so here we've got a spring that applies the force to cause the braking through the shoes on the drum. And if you want this to be fail safe, then we'll have a solenoid here that pulls against that, opens up pulls the shoes away from the drum, so that we have this drum free to rotate. Then if power goes off, the spring re-engages the brake. Okay, again, spring applied. So here we've got a slip clutch. So the springs in here provide the force to push the two plates together, and then you can adjust. Oh, excuse me. You can adjust the tension or compression in the spring, so that you can adjust the torque level at which the clutch will slip. Pneumatically activated. Okay, so here got an airline, some kind of airbag around here that expands to force the friction pad against the drum to either brake or to transmit rotational load. Hydraulically activated, so we talked about this before. So for the caliper, disc brakes have hydraulic force or pressure that forces the brakes pads together to clamp on the disc. Electromagnetic, so you can use the electromagnetic fields to achieve the same thing. We're not going to spend any time doing that, it's just there for completeness. Another way of electromagnetically activating a clutch or a brake, and you've got a link there to a YouTube video that you can go watch. More electromagnetically operated clutch or brake, clutch brake module. Okay, so here we've got both together, as we discussed earlier. All right, so that's enough for that intro. Next, we'll have a look at some performance parameters and start to look at designing some clutches and brakes. All right, so that's it for now. Catch you next time. Bye.